video is dealing with scientific notation form of a number, and um, very small or very large numbers, it is hard to write, and it will take a lot of space. Therefore, a different form of writing and expressing a number, especially when they are very small or very large, is the scientific notation form of writing it. When we are writing a number in scientific notation form, what we are uh, seeing is a decimal part of the number, and then times 10 to the power of an exponent. Now, the decimal part of the number has to be greater than or equal to 1 and less than 10. So it cannot be, let's say, 10.5, but it can be 1 times 10 to the power of. And the exponent is a whole number, which can be a positive or a negative whole number, positive or negative whole number. When we are dealing with numbers like very large numbers, like the distance between the center of the earth and the center of the sun, then those numbers is very difficult to express because they are into 10 to the power of something, positive 15, I think, kilometers. Or when we are talking about, let's say, the charge of the electron, 1.6 times 10 to the power of negative 19, a very small number. And on this case, it is very difficult to write those numbers. Therefore, um, the scientific form of writing a number, of expressing a number, it is helping us to, one, safe place, two, understand better. And another thing, if we tie it up with what we said in the previous one, the um, the leading zeros are not significant in a measurement. So therefore, when we have a number that is, let's suppose the mass of the electron 9.11 times 10 to the power of negative 31, when we are 9.11 times 10 to the power of negative 31 kilogram is the mass of the electron. If we are expressing this into standard form of the number, what we will have is 31 zeros, and I will stop the video here and then you will see the whole thing. So it will be something like this. And in total here we will have 31 zeros, and then after zeros is 911. So it is taking a lot of space, it is taking a lot of time even for me to write this. I had to count it several times to make sure that I have 31 zeros. So a nice way to express this number is to write it into a scientific notation form of the number. This is known as a scientific notation. And when we have a number, like a normal number, like numbers that you have seen since grade 1, since you are started introduced to math, is standard form of the number. You should be able to move from the scientific notation to standard form, and from standard form to scientific notation form. So let's see some examples into how can we move from standard form into scientific notation form. Let's suppose that we have this and we are writing it into scientific notation form. What we are doing on this case is we are moving the decimal point. So the decimal point is here, and then we are moving it 1, 2, 3, 4, 5, right after the first non-zero digit. So on this case will be 6.2, and then 1, 2, 3, 4, 5 steps. That we moved at the decimal point will be the exponent. Since this is a small number, the exponent will be a negative number, and when it is a large number, the exponent is a positive number. So when we have this, the notation form of the number will be of the same number will be 6.2 times 10 to the power of negative 5. When we have a large number, like let's suppose that we have 4, 3, 5, 8, and then a bunch of zeros, even though that we do not write the decimal point here, the decimal point is obviously it's here. So now what we are doing is we are moving the decimal point to form that decimal part of the scientific notation form. So to the very first non-zero digit, but not the first that you see, the very first one that it is in the number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll be here. And then to write the scientific notation form of this number, what we will do is we'll write 4.358 times 10 to the power of 9. Now, when you are moving from left to right, the exponent is a negative number. And when you are moving from right to left, the exponent is a positive number. In other words, when you have a small number, the exponent is negative, and when you have a large number, the exponent is positive. Now let's see how can we move from having a number in scientific notation form and expressing it into a standard form of the number. So let's suppose that we have this 4.25 times 10 to the power of negative 5. When we see this, then the decimal point, so this is a small number, okay? Therefore, we'll have a bunch of zeros in front. A clue here is that you will have as many zeros as in total as the exponent here is. So 1, 2, 3, 4, 5, and then you will have the other digits. And if you have a number that is to an exponent that is a positive, so let's suppose that you have 9.23 times 10 to the power of 4, and this is a large number, which means that the decimal point will move 4 steps. So you will have 9, 2, 3, 9, 2, 3, and then here was originally the decimal point, so you will move it 4 steps, 2, 3, and 4, and then those places are filled with zeros, and this will be the standard form of writing a number. When you are adding or subtracting numbers that are expressed in scientific notation form, you have to keep in mind that you will use those significant digit rules that we explained in a previous video. So when you are adding, you will go with the smallest, expressing the final answer with the smallest digit after the decimal point. And when you are multiplying, you are expressing the final answer with the smallest significant digits in total. So on those cases that we have seen, this number has 3 significant digits. This number has 3 significant digits as well. And this has 4 significant digits. This has 2 significant digits. This has 3, and so on. So the significant digits is only the counted for the decimal part, because the times 10 to the power of it doesn't have any value into it. Now, why do we use this, and why is it important to know the scientific notation form of writing a number? It's because you will see a lot of numerical responses in your course of sciences, and you have to record those answers. So what will you see in a numerical response is something like express your answer in the form A dot BC times 10 to the power of D. And if your final answer is, let's suppose, 3.25 times 10 to the power of 2, then what you will record into your numerical response box will be just the digits 2, 3, 2, 5, and 2. Okay, not decimal and not the exponent. If your answer is expressed in scientific notation form, or it is you are asked to express your answer in scientific notation form as A dot B times 10 to the power of CD, and you are asked to record the digits A, B, C, D, and let's suppose that based on your calculations, your answer is 2.5 times 10 to the power of 13, then what you will record as your answer in the numerical response sheet is just the digit 2, 5, 1, and 3. Okay, not decimal, not the power, not expressing the power or anything like this. If you have a case where you have a final answer expressed in the form A dot BC times 10 to the power of negative D, which means that you are dealing with a small number, and your result is, let's suppose, 2.53 times 10 to the power of negative 7. Again, what you will record is only the digits, not negative, not the decimal. So just 2, 5, 3, and 7. And if it is a very, very small number, like that they are asking you to express it into the form A dot B times 10 to the power of negative CD, and your answer, final answer, is, let's suppose, 1.5 times 10 to the power of negative 12, then again what you will record is only the digits as 1, 5, 1, and 2, not the decimal, not the negative sign. That's it for scientific notation.